Okay, hi everyone. Welcome to the Young Man Education. So today I want to discuss the Cambridge International AS and A level Mathematics 9709/1, Paper 5 Poverty and Statistics 1, October/November 2020. Alright, so now we try looking at the question 1 first. Okay, let's see the question 1. Two ordinary fair dice, one red and another other blues are thrown. Even A is the score on the red die is divisible by 3. Even B, the sum of the two score is at least 9. Okay, so now we try to think things out. Okay, one dice numbered. We have 1, 2, 3, 4, 5, 6, right? Okay, and then you see blue color and red color also are fair dice. So we can consider 1, 2, 3, 4, 5, 6 lah, okay? And then now we try draw the diagrams first. Okay, this is for blue. Okay, right here. Okay, 1, 2, 3, 4, 5, and 6. Okay. And this is a red. Also show 1, 2, 3, 4, 5, 6. Okay. So I can try to sketch the lines here. Alright, so now I try to draw straight line here first. Okay, let's see. Because now we need to find the property A and B, right? So let's see. Okay, so the A is the score is divisible by the trees, right? And then you see the events B is the sum of the two score is at least divisible by 9. Okay, so I will try to using the B, okay, for this diagrams, for this table, okay. So let's try out. So 1 plus 1, you will get 2. 2 plus 1, 3. 4, 5, 6, 7. Okay, here is 3, 4, 5, 6, 7, 8. Here is 4, 5, 6, 7, 8, 9. Okay, so we just continue. Okay, 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10, 11. 7, 8, 9, 10, 11, 12. Okay. Okay, so let's see. Score on the red is divisible by 3. Okay, if can divisible by 3. Okay, so can divisible by 3, we take number 3 here. Okay, this is for red. So we looking focus on 3 and 6 because number 3 and 6 can divisible by 3. Okay. And then now we're looking at the columns for the 3 and 6. Okay. So let's see. Okay. 4, 5, 6, 7, 8, 9, right? But you see the event B say at least 9, right? So we're looking at the 9. Okay. 10. Okay. 9, 11, and 12. Okay. And now you see how many samples here. 36, right? So you can take P, A, and B equals to 5 over 36 here. Okay, so now we try going to the next question. Okay, question B. Hence determine whether or not the events A and B are independent. Okay, so now we need to know these events are independent or not. Okay, we can apply the formulas here. Okay, let's see. Let's see the probability for event A. Okay, so you will get how many values here? Let's see. Okay, because you can see, okay, 2 over 6. Okay, why is 2 over 6? Because you see, a number say it's got 6 number, right? We just choose as 2 numbers only. Okay, so 1 over 6. Okay, simplifies 1 over 3. PB, okay. And then let's see the PB. Okay, is 5 over 36. Okay, so let's try. Okay, we take PA multiply PB equals to 1 over 3 multiply 5 over 36 equals to 5 over 108. Okay, so let's see. Okay, because we get the number actually is a difference. Okay. Eh, oh, sorry, actually it's not 5. Actually it's 10. Sorry, because actually we need to see 1, 2, 3, 4, 5, 6, 7. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, 10. Not 5. 5 over 6. Actually it's 10. So it's 10. Okay, 5 over 54. Okay, so let's see. The probability for A and B equals to 5 over 36, right? So you see this number is difference, not equals. So we can say evens A and B are not independent. So the even A and B are not independent. Okay, let's looking at the next question. Okay, now you see the question 2. Okay, the probability that a student at a last music college plays in the band is 0.6. For a student who plays in the band, the probability that she also sing in the chorus is 0.3. For a student who does not play in the band, the probability that she sing in the chorus is X. The probability that randoms choose a student from the college does not sing in the course is 0.8. Okay, so you see this sentence, right? You need to know how to analyze it out. Okay, so let's start. Okay, uh, last music playing. Okay, wait a minute. Okay, so all right, now let's start. Okay, I can try to list out first. Okay, this probability for the last music college. Okay, college. Okay, so we can take student at a large music college, okay, plays in a band, okay, is equals to 0.6. Okay, okay, for now you see, okay, for a student who plays in the band, right, the probability she also sing in the chord is 0.3. Okay, what is the difference is, okay, now you see the center question is she, not a large music property. So they will more focus on the individuals student only. Okay, so let's see. Okay, she sing in the chords. Okay, equals to 0.3. Okay, and then C P. Wait a minute. Okay, she will sing in the chord equals to X. Okay, for this, for student who plays in the band. Okay, and then this probability is for a student who does not play in the band. Okay, and then now you see the last sentences. The probability that random choose from the student college does not sing is in the chord is 0.8. Okay. Okay, does not sing in the chord. Okay, equals to 0.58. Okay. And then now you see, okay, for the last is 0.8, right? So we need to more focus on the 0.5s lah. Okay. And then now you can try doing the three diagrams here. Okay. 0.6. Okay. Okay, this is for place in the band. And this is for place does not play in the band. So now you need to know how to separate. 0.6 is for place in the band. 0.4 is for does not play in the bands. Okay, it's play in the bands, right? She will sing three for the property, okay? 0.3 is she sing in the chord. 0.7 she does not sing in the chord. Okay, and then you see, okay, does not play in the bands, right? Okay, the probability will sing is X probability. She sing in the chord. And then we can take 1 minus X when she does not sing in the chord. Okay, so we can see this uh three diagrams here. Okay, so we already know how to analyze it out. Okay, so we just more focus this. Okay, so you can take 0.6 multiply 0.7 plus 0.4 bracket 1 minus x equals to 0.5 x. Okay, so you can use the calculator here. 0.6 multiply 0.7. Okay, so you will get 0.42 plus 0.4 minus 0.4x equals to 0.5x. 0.4x will be equals to 0.24. X will be equals to 0.6. So your answer is 0.6 here. Okay. Okay, let's looking at the next question. B. Okay, two students from the college are chosen at random. Find the probability that both students play in the bands and both sing in the chorus. Okay. Okay, two students, right? So okay, let's see. Both students. So it means you take 0.6 multiply 0.3 and then multiply square. Okay, because two times okay, because two students, so you multiply two times. Okay, and then you will get the answer equals to 0.0324. Okay, so let's going to the next question. Question 3. Okay, CAIA is completing the in the throw events. A throw is counted as a success if the distance achieved is greater than 30 meters. The probability that CAIA will achieve a success on any throw is 0.25. A. Find the probability that CAIA takes more than 6 throws to achieve a success. Okay. So when you see this, right? Okay, this part, it means they need to repeat. They want to repeat many times until he can access or can success for these events. So we will using the geometry distributions. Okay, because you can see this keyword. You need to repeat. Okay, repeat many times. Okay, so until Kaya can be accessed. Okay, so let's try. Okay, so we now need to apply the geometry distributions. Okay, so the question is asked is more than 6, right? So we can apply the formulas here. When x more than x, we can take q, q's right? Wait a minute, q x here. Okay, when x less than or equals to x, you take 1 minus qx. Okay, so now you see it's more than, so you take p when x more than 6 equals to 0.756. Okay, so you will get the answer is 0.17x. Make sure your answer right in 3 significance figure. Okay, let's see to the question B. Find the property that a random sample of the 10 throws can achieve at least 3 success. Okay, for this question, you need to apply the binomial distributions. So I hope you can know uh, how to define or no, because okay, when you see the keywords random sample of the 10 throws, so you see the samples, right? Yeah, so we will apply the binomial distributions. For the question A, you see they didn't give you any samples, right? And then they will say, okay, they will take many times, okay, to throw until a success. So it means you need to repeat. When you see the not keywords, okay, when you see this distribution, you need to repeat or repeatedly So you need to apply the geometry distributions. Okay. And now let's see the question B. Okay. Sample is 10, right? So it means n equals to 10. Okay. They achieve at least 3. So you can take P when x more than or equals to 3. So you can write here 1 minus when P less than 3. So 1 minus when Px equals to 0 minus x equals to 1 minus x equals to 2. Okay, so you can take 1 minus, okay, let's start. 1 minus, take 10, don't take 10. Also can. So you can take 10C0, 0.25 power 0, 0.75 power 10. Okay, minus 10C1, 0.25, 0.75 power 9. And then minus 0.C2, okay, 0.25 square, 0.75 power 8. Okay, so we start to calculate the values. 0.75 power 10, you will get 0.056314 minus, okay, 0.18771 minus, okay, 0.28157. Okay, so let's find out the answer. 1 minus 0.056314 minus 0.18771 minus 0.28157. Okay, so you will get the answer is 0.474. Okay, make sure your answer in 3SF. Okay, so let's go into the next question. Question 4. The random variable x tested each of the values 1, 2, 3, 4 with the probability 1 over 4. Do independent values of the x are chosen at a random. If the two values of the x are the same, the random variable y take the values. Otherwise, the value of the y is largest value of the x minus smaller value of the x. A. Draw up the probability distributions for the y. Okay, so you see these keywords, right? Okay, so let's see how to do it now. Okay, okay, this is your x, right? X, you got two values here, 1, 2, 3, 4. 1, 2, 3, 4. Okay, if you get the same numbers, right, the random variable will take the value. Okay, let's say, okay, if you get the value is 1 and another x also 1, right? So your y, you will take 1. Okay, if your x get number 2 and here is x number 4, right? So we will take number 4 minus number 2 equals to 2. I hope you can get this meaning. Okay, so we can start to draw the diagrams first. Okay, so this is your x, 1, 2, 3, 4. Okay, and here also same, 1, 2, 3, 4. Okay, let's see. 1 and 1 you will get equals to 1. 2, 3, 4. Okay, for this part is same. Okay, now you see, okay, 2 and 1s, right? For this part, you will get 2 minus 1, you will get 1. 3 minus 1, you will get number 2 is here. 4 minus 1, 3. Okay, 2 minus 1 equals to 1. So, okay, 3 minus 2, 1. 4 minus 2, 2. 3 minus 1, number 2. 3 minus 2, okay, 1. 4 minus 3, 1. Okay, and then 4 minus 1, you will get 3. 4 minus 2, 2. 4 minus 3, 1. Okay, so you can see, okay, you see this red part, right, is for random variable y. Okay, so this is your random variable for the y. Okay, let's see what is the number here. Okay, 1, 2, 3, 4. Okay, so you see what number got 1, 2, 3, 4 here, and then you can labels here. Okay, y. Okay, y when probability x equals to y, 1, 2, 3, 4. Okay, so let's calculate the probability first. Okay, so you can see here is total sample is 16, right? Let's see, okay, how many numbers for the number 1? Okay, so you see 1, 2, 3, 4, 5, 6. So you can write, how many? Oh, 7, sorry. 7 here, okay. Number 2, okay, we see how many? 1, 2, 3, 4, 5. So 5, 16. Okay, 3 is 3 over 16. 4 is 1 over 16. Okay, so this is your answers for question A. Okay, now we try looking at the question B. Find the probability that y equals to 2, given that the y is even. Okay, so you can write here, let A equals to, okay, even A, when A equals to even of y equals to 2. B, okay, let even of y is even. Okay, so you can write here, okay, A stroke B equals to A and B bracket B. So let's see, okay, we find the probability y is even. So you can take, okay, C is 4 and 5, right? So you can take 5 over 16 plus 1 over 16 here. Okay, and then you see, okay, n. Okay, it means you need to get 2 and the same time also evens, right? So you take 5 over 16 here. Okay, so you will here get 5 over 16, here is 6 over 16. So you can cancel. So you will get the answer here is 5 over 6. Okay, let's looking at the next question. Question 5. Okay. The times in hours that Devi plays on his game machine each day is normally disputed with the mean 3.5 and standard deviation 0.9. A. Find the probability that on a random choose day plays on his game machines for more than 4.2 hours. Okay, so you can write here P x more than 4.2. So we need to change to standard normal variables. Okay, so okay, now I need to open my tables first. Okay, so let's start. Okay, so you can take z more than 4.2 minus 3.5 over 0.9. Okay, so P when Z more than over 0.9, so you can write 0.778. Okay, you see it's more than, right? So you should be to take less than. Okay, 0.778. Okay, now I sketch the graphs to you. Okay, so you try to find 1 minus 0.7. Okay, 7. Okay, so you can take 0.7794 plus. Okay, 8 is 0.0024. 1 minus bracket 0.7794 plus 0.0024. Okay, so you will get 0.218 here. Okay, so this is your answers. Okay, so now we try going to the next question. Question B. On the 90% of the days, David plays on his game machines for more than T hours. Find the values of the T. Okay, so P when X more than T's right equals to 0.9. So we change to standard normal. T minus 3.5 divided 0.9. Okay, bracket equals to 0.9. And then I try to sketch the graph here. Okay, you see, it's more than, at the same time is, the probability is 0.9, right? So you should be to sketch or labels here. So, and then if you want to write a standard normal variable, make sure to take the negative sign, okay? Make sure to take the negative sign here. Don't forget, okay? Because now is the standard normal variable is at the negative value. Okay, and then now we try to find, okay, 0.9, how to find it out. Okay, so you can take 0, okay, right here. Okay, so you can take 0. Okay, see in the table 0.8997 plus, okay, 0.0002. So will be equals to 0.8999. Actually, it's nearest lah. Okay, so you just take negative 1.28. Okay, 281. Okay, so your T will be equals to, okay, so it will equals to 2.35 hours. Okay, let's look at the next question. Okay, question C. Calculate an estimate for the numbers of the days in the year 365 days on the which David plays on his game machine for between 2.8 hours and 4.2 hours. Okay, so let's start. Okay, this P 2.8 X 4.2. Okay, so now we need to change to standard normal variables. Okay, so you can take like, okay, 2.8 minus minus what, okay, 3.5 divided 0.9. Okay, Z 4.2 minus 3.5 divided 0.9. Okay, so 2.8 minus 3.5 over 0.9. So, okay, negative 0.778. Z, okay, here is get positive 0.778. Okay, so you can totally write two symbols, okay, 0.778 minus 1. Okay, so how to find this value? Okay, you can take from the part 1. So, okay, now you can write here 0.7794 plus plus 0.0024 minus 1. Okay, so you will get equals to 0.5636. Okay, now you can try to find out the estimate number. Estimate for the number of days. So you can take 0.5636 multiply 365 days. So you will get the answer is 5.714. But I write the answer in 200 day, 6 days. Okay, so this is your answers. Okay, now we try looking at the next question. Question 6. The times t minutes. Okay, take us 115 students to complete, okay, a particular challenge are summarized in the following cumulative frequency tables. Okay, A, draw a cumulative frequency graph to insulate the data. Okay, so you need to draw lah, how to start to draw. Okay, so it's T, okay, cumulative frequency. So maximum is 115. So let's see, okay. Okay, so I can write here 0, 10, 20, 13, 14, 15, 16, 7, not enough. Okay, not enough, so I need to use 10, 20, 14, 16, 18, 100, 120, 114. Okay, and then 116. Okay, so this part is cumulative frequency. Okay, cumulative frequency. Okay, and then here is time. So it's until 100. Time taken. Okay, minutes. So you can write here 20, 14, 16, 18, 100. Okay, so let's start now. Okay, 12. Okay, 12 is until 2, 4, 6, 8, 10, 12. Start 0. And then, okay, if less than 30, 48. So 2, 4, 6. Okay. Okay, 14, 106. 2, 4, 6. And then 16, 113. 34. 2, 4. Okay. 115. Okay, it's until here. So you can start to draw. Okay, so this is your cumulative frequency graph. Okay. Okay, so let's go into the next question. Okay, question B. 24% of the students take the K minutes or longest to complete the challenge. Use your graph to estimate the values of the K. Okay, you see it says 24%, right? Okay, this is your cumulative frequency graph. Total is 50%, right? And then the question say, here is K, okay, or more than, it means the last 24%, okay? So we can use the another ways. We can take 76%. So you can take 115 multiply 76 over 100 equals to 140. Okay, so we can try. Okay, find 114 to 10 to 4. 114. Okay, so you can label the answer here. Uh, 2, 4. Okay, 44. So your answer K equals to 44 minutes. Okay, so this is your answers. Okay, let's looking at the C. Calculate the estimate of the mean and the standard deviations of the time taken to complete the challenge. Okay, so all right, now you see, okay, you need to find the frequency and midpoint. Okay, you need to find. So how to find it? Okay, so wait a minute. Okay, wait a minute. Okay, see here. Okay, this is your midpoint and this is your frequency. Frequency. Okay, so midpoint. Okay, let's see. Here is 20, right? So take 20 plus 0 divided by 2 equals to 10. Okay, frequency same. Okay, 12. And then let's looking at 13. So you should be to take 20 plus 13 divided by 2 equals to 25. Okay, and then you see the frequency. Okay, 48. Right? You take 48 minus 12. You will get 36. Okay, 36. And then we see the another. Okay, take 14 plus 13 divided by 2, 35. 35. Okay. And then you can take 106 minus 48. So you will get 58. Okay. And then now you see again 16 plus 14 divided by 2, 15, right? Okay, so you see 15, 15. Okay. And then 15, right? Okay, take 134 minus 106, you will get 28. Okay, and then now we see, okay, 100 plus 16 divided by 2, you will get 18. Okay, for the midpoints. And then we find the last frequency, okay, 115 minus 134, you will get 16. So we already find out these values here. Okay, so we can start to find the means first. Okay, so we find the mean. Okay, mean equals to 10 multiply 12. Okay, for the total frequency is 115. So you don't need to write 12 plus 36 plus 58 plus 28 plus 16. Don't need, okay. And then here is take 25 multiply 36 plus 35 multiply 58 plus 15 multiply 28 plus 18 multiply 16. Okay. Okay, we calculate for the numerator parts. Okay, so you get 5,713 over 115 equals to, okay, 38.2. Okay, so now you can find the variance first. Okay, variance. Okay, so you can take 10 square multiply 12. Okay, multiply 12 plus 25 square multiply 36 plus 35 square multiply 58 plus 15 square multiply 28 plus 18 square multiply 16 over 115 minus 38.2 square. Okay, let's calculate. Plus 25 square multiply 36, 35 square multiply 58 plus 15 square multiply 28 plus 18 square multiply 16. Okay, so you get 267,115 over 115 minus 38.2 square. Okay, so you can get your final answer here. Okay, so your answer is, okay, answer here is, okay, 321.76. But you see the question says find the standard deviations. So we know standard deviation equals to square root variance, okay? So you can take equals to square root 321.76. Okay, so your answer is 17.9. Okay, so we already finished the question 6. Now we see the question 7. Find the number of different ways in which the 10 letters of the word shopkeepers can be arranged so that all three are together. Okay, let's see, analyze these keywords here. Okay, so you see how many E? 3E, right? Okay, 3E, S, H, O, P, K. Okay, you see got 2P. Okay, 2P here. And then S, H, O. And then K, R. So S, S, H, O, K, R. Okay, so E3 and 2P6. Okay, so we already analyzed out. And then you see, okay, 3 is together. Okay, so it means 10 letters. 2, 4, 6, 7, 8. Okay, so if 3 letters together, right? Okay, so we consider one position. 2, 3, 4, 5, 6, 7, 8. Okay, wait a minute. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorry, I write more. Okay, so we have 8 positions here. Okay, so they will start to move it. Okay, okay, so how to calculate? Okay, so we can write here. Wait a minute. Okay, so we have the 8 positions here, right? And you see, we have 2p here, 2p. So you should be to take 2 factorial. So I take x factorial over 2 factorial equals to 20,160. Okay, let's looking at the P. Find the number of different ways which the 10 letters of the word shopkeepers can be arranged so that the P are not next to each other. Or when you see these questions, right, also seems you find the total Okay, numbers way. Okay, and find the when p is together. Okay, so let's see total number of ways. Okay, C got 10 letters, right? So you can take 10 factorial divided 3 factorial multiply 2 factorial. Why? Because you see 3e and 2p. So you can take 3 factorial and 2 factorials. Okay, so you will get is 302400. And then now you try to find with p as together. When p is together, right? Okay, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so when p is together, okay, consider one position. 2, 3, 4, 5, 6, 7, 8, 9. So here it's got 9 positions. So you take 9 factorial divided by 3 factorial. This 3 factorial is because for e, 3e. Okay, so I can take 9 factorial divided by 3 factorial equals to 60,418. Okay, so now I can find with PS are not next to each other. Okay, so you can take other, so you can take 302400 minus 60480 equals to uh 241,920. Okay, so this is your answers for the question B. Okay, let's looking at the question C. Find the probability that a random choose the arrangements of the 10 letters of the word shopkeepers has an E at the beginning and the E at the ends. Okay. Okay, so we already know we have three E's, right? Okay. 3E, 2P. Okay, 2P, and then SHOKR. SHOKR, right? Okay. So let's see. If the E is here, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, it's 10. So for this 8 space, right, we have 8 letters can use. Okay, so we can use E, 2P, S, H, O, K, S, right? Okay, now we need to find the probability. Okay, so we find this arrangement first. Okay, so you can take 8 factorial divided by 2 factorial will be equals to, the 2 factorial is for 2p. So the answer is 20,116. Okay, so now you can try to find the probability equals to 20160. Okay, the total is 302400 equals to, okay, so you can try to simplify the answers. Okay, so you will get the answer is 1 over 50. Okay, so that is your answers for the question C. Okay, now we see the question D. The 4 letters are selected from the 10 letters of the shopkeepers. Okay, find the number of the different selection if the 4 letters include the X, include 1P. Okay, I already mentioned many times for the previous video. If you see these questions, right, please don't using the probability to calculate out the answers. Okay, use the selections. Okay, number of the selections to calculate. Because I know this question they was more confused to the student. Because some student they were confused using the probability to calculate these questions, or sometimes they were using the selections when the question is come out is probability. Okay, so please, okay, please don't do this big mistake in your exams lah. Okay, and then you see the keywords here. Okay, because we already know 2Ps, right? 2Ps, 3E. Okay, S H O K R, right? So we have these letters, and then the question says exactly 1P. Okay, so we say P, and then we take 4 letters. Okay, let's say 1P, 1E, 1P, 2E, here, 1P, 3E, okay, and 1P, no E. Because the question they didn't say you must have the 1E or 2E or all the E's, right? So we can consider no E's here also can. Okay, and then let's see. Okay, we have 2 letters here, right? So you can take 5C2. Okay, this is for another letters. Okay, 5C1. Okay, and then you can take 5C0. And the last is 5C3. So 5C2 equals to 10. 5C1 equals to 5. 5C0 equals to 1. 5C3 equals to 10. Okay, so the total number of the selections equals to 26. Okay, so we already finished for this paper today. Okay, if you like this video, please like, share, and subscribe. Okay, I will try my best to upload the new videos. I will see you in the next video. Goodbye, everyone. Goodbye, my students.